Hi friends, in this particular video I am giving you brief idea about how to interface 8086 with external latches and trans receivers, especially in minimum mode. So here we will discuss about minimum mode operation of 8086. So in the introduction of 8086 I already explained 8086 operates in two modes, minimum mode and maximum mode. In minimum mode all control signals are generated by the processor only. Okay. So with the help of those control signals, processor will controls latches as well as trans receivers. Okay, let us see how to analyze the minimum mode operation. See the problem? Okay, now let us see this particular part. There is a clock generator. So this is very essential. Role of clock generator is it will give you three important pins information to 8086. In that one is ready. See here, ready. Okay, one is ready. Then other two are clock, then reset. See here, the 8284, nothing but clock generator IC number is 8284. This 8284 is communicated to 8086 with the help of three pins: reset pin, clock pin, and ready pin. Let us see. So this is your 8284. Now pin number 8. What is pin number 8? Clocks here. This is clock. So the clock, see here, clock of 8284 is connected to processor clock. Okay, so simply processor clock pin receiving a clock signal from the clock generator. So this clock generator may generate clock frequency of value 5 MHz with the help of crystal oscillators. Here, this crystal oscillator, the maximum frequency range is 15 MHz. So by adjusting the values of this crystal oscillator, we get the 5 MHz. That 5 MHz frequency signal is transmitting from this clock 8 to clock of 8086. Then other is reset. See here, pin number 10. Reset pin number 10 of 8284, nothing but clock generator, is connected to reset of processor. So I already mentioned this reset pin must be activating for at least 4 machine cycles for every new operation. During that time, except code segment register, all other registers content is cleared, flag register content is cleared. Okay, except the code segment register, all other segment registers are cleared, flag register cleared, and code segment register is fetching with the value of 4FH, and the next instruction is fetching from the address 4F0H. Like that, this reset instruction makes that particular thing automatically. Okay, so then other is then other number is 22, nothing but ready. In 8086 it is ready, whereas 5 is also ready. So which three are very important? Ready pin, clock pin, then reset. These three are very essential, and these three pins of 8284 is connected to processor. Okay, and the remaining pins are there, X1, X2. These two connected to external crystal oscillator, power supply pin, clock synchronizing pin. Okay, 8284 also there is one more ready one pin. Like that, some pins are present, but as per our minimum mode operation of 8086, only these three are essential. So this see clock, ready, and reset of 8284 connected to processor. So now let us see what is minimum mode. See here, this is the minimum mode operation of 8086. So in that there is a 8086 CPU. So here we have 40 pins. Then there is a clock generator. Number is 8284A. 8284A. Then there is a latch. Number is 8282. Here we are taking 3 latches. 1, 2, 3. 3 latches. So that's why number is 3. Here why I am indicating 3 means because of 3 latches. Okay, then this is trans receiver. You know, trans receiver transmitting or receiving data, it is possible with the help of trans receiver. Here also we are taking 2 trans receivers. So why we are taking two transceivers? Because reason is we have 16-bit data. So the size of 8086 processor data bus is 16-bit. Because of 16 data lines, we need two transceivers. Two transceivers are required. So output of transceiver is bidirectional data. Okay, whereas address is unidirection. Right. Now similarly we have some control pins related to transceiver and say related to latch also. Okay, let us see in detail. Okay, these are the pins that are present. So coming to first 8086. So we know in 8086 what happens, we have 40 pins which are required, I am indicating here. Now let us see first 8086 receiving 3 pins information from the clock generator. One is clock, ready and reset. In the last slide I explained. So these 3 signals are coming from the external clock generator. Okay, with the 5 MHz clock frequency coming from the clock generator to clock, ready also coming. Okay, then reset signal also coming from the clock generator, these 3. So then coming to for selection of minimum mode, the Mn by Mx bar signal must be high. High means VCC, or if you connect 1 also. Then we are selecting which mode? Minimum mode. In minimum mode, all control signals are coming from the processor. So your latches, transceivers, all are controlled by processor only. Let us see in which way it is controlled. For example, here I have 20 multiplexed, actually 21 multiplexed lines are present in 8086. What are those? First AD0 to AD15. So these 16 are multiplexed address and data lines. We are sending these multiplexed address and data lines to latch. Okay, so in latch there is two important controlling pins. One is OE bar. OE bar is output enable bar. It is connected to ground. Okay, then it is activating. Then other is STB, nothing but strobing pin. This strobing pin is connected to ALE. ALE. What is ALE? Address latch enable pin, and this pin must be high during T1 time. Nothing but first part of the machine cycle. So if you give ALE equal to 1 during T1 time, and that information is given to STB, accordingly STB, actually this STB nothing but it's a combination of 8 D flip-flops common point. So each latch having 8 D flip-flops. So all those latches, the common point is STB. That STB is now connected to ALE means automatically it will take multiplex address and data lines, make it like a pure line. Like that one latch can separate 8 lines only. But here we have 16 address and data lines, 4 address and status lines, and one BHE bar slash S7. This is BHE bar S7. This is A16 slash S3 to A19 slash S6. Like that, 16 here, 4 here, and 1. Total 16 plus 4 plus 1. Total 21. So 21 multiplex lines are present here. So in order to separate these, we are taking 3 latches. Okay. Further, we are activating STB with the help of ALE signal, and OE bar is ground. Based on these 3 latches, what happens? We get pure address lines, nothing but A0 to A19 here. We get A0 to A19. Similarly, we have status lines also. S0 to S4, S5, S6, S7 are coming. Okay, similarly BHE bar is also coming from the latch. They are separating. So after separating address lines into pure address lines, we get data lines. Those data lines are transmitted to transceivers. Here, data lines are now moved to transceiver. Because of 16-bit data bus, I am taking 2 latches, 2 transceivers. The role of transceiver is it can transmit 16-bit data or receive 16-bit data. Okay, so nothing but transceiver act like a mediator between 8086 and external device. Okay. Now for transceiver also we have 2 pins. One is OE bar, nothing but output enable bar. Then T. T is transmit. Okay, T is a 1 pin. 2 pins are must be activating. So OE bar is now connecting to DEN bar. So what is DEN bar? In pin description I explained. DEN bar is data enable bar. If this data enable bar is activating, then only data lines are ready for transmitting or receiving through transceiver. So for that reason, DEN bar must be enabled during T2 to T4 time. Okay, that information is given to OE bar, then OE bar is ready to transmit or receive data. Okay, then DT by R bar, this is also very important. DT by R bar is connected to T. For data transmitting means processor sending data to external device, then DT by R bar should be 1. Okay, DT by R bar should be 1 if processor sending data to external device through transceiver. For example, processor wants to receive data, then DT by R bar should be 0. Then it will receive the data. So like the DT by R bar should be 1 or 0 depending on the transmission as well as receiving. Okay, accordingly transceiver sending the data to external device or receiving data from the external device and passing to processor. Okay, and the other signals that are present in the minimum mode is M by IO bar. Okay, whether we are selecting memory or IO decided by M by IO bar. Similarly, write bar read bar, hold, HLDA. These two pins I already explained. These two pins are accessing the process system bus by external peripheral. Okay, hold signal for requesting the accessing process system bus. If processor is ready, it will send a hold acknowledgement signal. After sending hold acknowledgement signal, then 8086 is giving permission to external peripheral to take it's a system bus. Then INTA bar and INTA bar and INTR. These two are also requesting the processor for executing its instruction. Okay, with the help of interrupt request and interrupt acknowledgement. If external device wants to execute its its instructions with the help of processor, then it will give information to interrupt request. If processor is ready, it will give you interrupt acknowledgement. After receiving interrupt acknowledgement, processor executing the external peripheral instructions. Like that, we have signals that are present in the minimum mode of 8086. So finally, the 8086 mainly receiving three signals from the external clock generator. One is clock ready and reset. Okay. Then for minimum mode selection, Mn by Mx bar should be connected to 1 or VCC. Okay. So now here we have 21 multiplexer lines are there in 8086, and those lines are separated into pure address lines, data lines and status lines with the help of 3 latches, and each latch can separate only 8 lines into pure address lines. But here we have 21. For that reason, we are taking 3 latches, and each latch having internally a set of 8 D flip-flops, and all flip-flops are connected to common point. Call it as STP, nothing but stopping point. This stopping point is connected to ALE. Whenever ALE is high, then automatically these lines are separating into pure address and lines, address and data lines, and similarly address and status lines easily. And here OE bar should be connected to ground. Similarly, transceiver role is transmitting or receiving data between 8086 and external device. And this transceiver also having 2 signals, OE bar and T. OE bar should be connected to DN bar, and T is connected to DT by R bar, and these are some of the control signals. Okay, like that we can analyze the minimum mode operation of 8086 easily. Okay. Okay. So thank you for watching this particular video. If you really like, please kindly share my video to your friends and subscribe my channel. Thank you.